Hello, and welcome to this module on encouraging functional thinking via cleverly designed collections. Really, the objective of this module is to familiarize you with the different types of Scala containers. Scala's containers include collections and non collection containers. The latter category include tuples, which are an excellent alternative to lightweight objects in object oriented languages such as Java. We will work with core Scala collections, lists, and maps, and lead up to the next module where we discuss higher order functions on collections in great detail. And we'll round off this module with a look at how options are used for good error handling in Scala. Scala has quite an intimidating array of containers. These include tuples, lists, maps, options, arrays, and mutable collections. If this alphabet soup of containers has you slightly worried, well, fear not. We can make a lot more sense of these containers by classifying them into three broad categories: immutable collections, mutable collections, and arrays and other constructs which are not collections at all. Immutable and mutable collections both implement the Java iterable interface. They reside in parallel namespaces. Immutable collections are, of course, the favored type of container in Scala because of Scala's strong preference for side effect free code and immutable data. We will devote particular attention to collections because they work with higher order methods. These higher order methods take in function objects and are powerful constructs that we will devote the entire next module to. Let's plunge in and let's get started. Tuples in Scala are really just like tuples in math. They are a bunch of values enclosed within parentheses. Tuples are a handy, lightweight way to pass data around without needing to set up a simple class as you would have been forced to do in Java. Tuples are ordered containers. The elements can be accessed in order as underscore one, underscore two, and so on. And those elements can be of different types. Tuples are not technically collections. All collections in Scala and in Java implement the interface iterable. Tuples do not. Rather, tuples implement a set of traits, tuple 1, 2, and so on, based on the number of values in the tuple. Let's jump into a demo in which we will demonstrate creating and using tuples, accessing the individual elements of a tuple, iterating over a tuple, and passing a tuple into a function. As always, let's begin in the Scala interactive shell, that's the REPL, and we create our first tuple simply by throwing together a bunch of values and enclosing them between a pair of parentheses. And Scala type inference does the rest. It figures out that we have a four element tuple in mind, and it figures out that the type of this tuple is simply a tuple consisting of the types of the individual elements. In this case, string, string, int, and string. There also is a really easy way to create a two element tuple that's a key value pair. That's using the arrow syntax or the arrow notation that you see highlighted on screen now. Here I create a simple tuple with my name and gender, and you can see that the key and the value are separated using an arrow. Next up, let's see how we can apply a function literal to every element of a tuple. Doing so requires this somewhat clunky syntax that you see on screen now. In order to apply a function object to every element in a tuple, we need to make use of this dot product iterator dot for each method. This method takes in an argument. That argument is a function literal, that is a function object, and then that product iterator dot for each will go ahead and apply that function object to each element of our tuple. That's what's done here on screen. We have a simple function object which prints the individual elements to screen, and the resulting output is what you see. Next up, let's talk about accessing individual elements of a tuple, and by far the easiest way of doing so is by specifying a bunch of values separated by commas and enclosed in parentheses on the left hand side of an assignment operation. When that happens, as you can see, Scala will assign the individual elements of the tuple to the values on the left. For instance, here I have four values. Each of those values corresponds to one element from our four element tuple, and the values are named first name, last name, age, and gender. If I had not been interested in one of these values, I would simply have specified an underscore in place of a value name. Another but very clunky way of accessing the individual elements is by making use of the dot underscore one notation. For instance, personinfo dot underscore one would give us the first element of the tuple, personinfo dot underscore two would give us the second, and so on. We have already spoken about how to apply a function literal to every element of a tuple. Let's now talk about how to use a tuple to specify the parameters into a function. It turns out that this is surprisingly complicated to do so. Scala's type inference is not able to automatically convert a tuple and pack it into a list of parameters, so we have to do so ourselves. We have here a simple function called print %gender, expecting two strings containing the name and the gender of a person. In order to pass in a tuple to this method, we've got to follow this rather complicated syntax on screen now. We have a function object. We take this function object and we invoke the dot tuple method on it. This accepts a tuple and packs the elements of the tuple into function parameters. It will go ahead and invoke the function with that packed set of parameters, and the result is what you see on screen. And one last handy operation that you might want to perform on tuples: if you would like to programmatically access the number of elements in a tuple, you've got to use the dot productarity method of the tuple object. Here, personinfo is a 4-element tuple, and so the dot productarity method returns the integer value 4.